Hi, I am Dr. T.V. Haimalakshmi, working as an associate professor in the Department of ECE in SRKR Engineering College. In this lecture, I would like to discuss the Huffman coding. This Huffman coding was developed by D.A. Huffman in 1952. Huffman coding is a popular image compression technique which is used to reduce the coding redundancy. In this Huffman coding technique, the smallest possible number of bits are being assigned to highest probability symbols. It can be used in lossless compression because it is a reversible. For example, if you take this image, in this image, suppose this image is represented by using the 256 gray levels, that is 0 to 250, 255 gray levels, and this image having the very few intensity values. That is, this is the one intensity value, and this is one intensity value or one color and one gray level, and this is the other gray level. Totally, if you observe, there are very few intensity values are used to represent this image. Suppose these intensity values are represented by A1, and these gray levels are represented by using the symbol A2, and these intensity values are represented by A3, and this white on some gray level, that is A4. Even it is represented by using, it may be 256 gray levels or 512 or 1024. There are, in this particular image, there are only few intensity values are used to represent this entire image. And suppose these intensity values, this image having these intensity values are 1000 pixels are having this intensity value, and suppose that A2, that is some other intensity value having the pixels 100. Similarly, A3 also 100 and A4 also 100. Suppose if it is represented by using a fixed length coding. Fixed length coding, that is, fixed length coding means the number of bits assigned to the each gray level or the fixed. Suppose that is 8 pixels, 256. If it is a 256, the number of bits assigned to each gray level or the 8. Suppose it is a 512, it is the 16 and 32. That is number of bits assigned to each gray level. Suppose if you take this example, that is smallest, that is one, that is 8 pixels, 8 bits. The number of bits used to represent each intensity value are the 8. Suppose there are 1000 pixels. So the 1000 pixels are represented by using the 8 bits. So the number of bits required to that intensity value are the 800. Similarly, for the intensity value A2, we are assuming there are 100 pixels are presented in that image, and the number of bits are the 8. So to represent this intensity value, the required bits are 100 into 8, that is the 800, and A3, that is also represented by using 8 bits if it is a fixed length coding, then it is also 800. Similarly, for this 8 A4, that is also 800. Then total number of bits required in fixed length coding are the, these are the 10,400 bits are required to represent this image. Suppose if you use the variable length coding, that is Huffman coding, variable length coding. In this example, we are taking that Huffman coding. In this Huffman coding, less number of bits are assigned to the most probably pixels. That is, here highest pixels are the 1000 pixels. Here the intensity value having the 1000 pixels. Suppose if we assign the less number of bits, suppose the code is the 0. Suppose here the highest pixels are the 1000 pixels, that is the A1. Suppose if you assign the code word is the 0 for the A1, and for the A2 may assign the code word 1, and for the A3 it may be 00 or 01. Then the required bits on 1000 to represent these 1000 pixels, it requires the 1 bit, that is the 0, and it is also 1 bit, and it is 2 bits, 2 bits. So the number of bits required in fixed length, this Huffman coding, that is a variable length coding, that is A1, there are, that is 0, 1000 pixels, 1000 into 1, those are only 1000 bits are required here. For A2, if you assign the 1 bit, that is the 1, binary 1, then number of bits are 1000 into 1, 100 into 1, those are the 100. And if you assign the 2 bits to the A3, then 2 into 100, that is the 200. Here also 200. Then total number of bits here are the 2 plus 2 5, it is only 1500 bits are sufficient to represent this entire image in Huffman coding. Whereas in fixed length coding, the number of bits required are the 10,400. We get this much of compression ratio by using this variable length coding or Huffman coding. Let us see with the examples. Suppose if we are asked that obtain the Huffman code for the word committee, and we may ask like obtain the Huffman code for the word mummy, obtain the Huffman code for the word apple or India, or like that. And by giving the intensity values and number of pixels having that particular intensity value. Suppose if you take this example, obtain the Huffman code for the word apple. Let us see how to get the Huffman coding for the word apple. The symbols used in this apple are the A, P, L, E. These are the symbols used in that word. First, you have to find the probability for the each symbol in that code. That is A. What is the probability of the A? That is the, it appears for the one time, and the total number of symbols are here are the 5. So the probability is 1 by 5, that is the 0.2. Similarly, for other symbols you have to find the probability, that is next for the P. The probability for the P is this P appears for the 2 times, and the total symbols are 5. So the probability for the P is the 2 by 5, that is 0.4. Similarly, for the L, that appears only one time, so the probability is 1 by 5, and for the symbol E also the probability is 1 by 5. First we have to arrange all these symbols based on the probability. We have to write the highest probability symbol first. Next you have to write all the symbols in descending order based on the probability. The highest probability, that is the P, that is 0.4. That remaining are the A, L, E are the probabilities are 0.2, 0.2, 0.2. You have to arrange all the symbols in descending order only. Then this least probability symbols have the highest number of bits, and the highest probability symbols will have the least number of bits. So we should arrange all these symbols in descending order only. We should not write in ascending order. We should remember that we have to arrange all the symbol in descending order based on the probability only. One landmark to remember how to write descending order or ascending order means, that is the Huffman coding, that is H, and descending order HD. How to remember that you have to arrange all the symbols in descending order only. That is Here the least symbols, that is 1 by 5, that is L, E, the probability is 0.2, 0.2. We have to assign the 0, 1, and we have to add these two probabilities, and we have to rearrange the probabilities in descending order again. That is 0.4, it is 0.2. This, when we add these two symbols, 0.2 plus 0.2, that will be 0.4. Then again we have to assign 0, 1 here and add these two probabilities and rearrange the all probabilities, all the symbols in descending order. That is, this addition of this will be 0.6. So we have to write the 0.6 here and 0.4 here, and how to arrange the 0 and 1 for these symbols also, 0, 1. Then we have to write down all the these code word bits. That is for the symbol P. That is the for the symbol P, the code word is G. That is the 1. Here for the symbol P, the code word is here. How to write this? That is the P is 1, and for the A, that A, it is the 1, 0. That is, we have to write here 1, 0. And for the L, it is 0. Next here we write this here 0, 0, 0. That is L, 0, 0, 0. For E, it is 1, 0, 0. We have to write in this order 1, 0, 0. If we take these code word bits from left to right, we have to write from right to left. That is, if we take the like this order 0, 0, 0 for the letter L. Okay, next for E, it is 1. While we taking left to right, if we take the left to right, then we have to write here right to left. That is, for the E, it is 1, 0, 0. Here we have to write 1, 0, 0. So these are the code words for these symbols. For the P, it is 1. For the A, it is 0, 1. For the L, 0, 0, 0. For the E, 0, 0, 1. That is the code words for the word apple. Next, if you another example. Another example for this Huffman code, that is for the word committee. Here the number of symbols are the 9. We have to find the probability for each symbol. That is, this is the formula to find the probability. That is, probability equal to probability of a symbol equal to total number of occurrence of symbol in a message by total number of symbol in the message. Here the probability of the symbol C equal to P of C equal to 1 by 9. That is, the occurrence of the C in is 1 time. And for the O, that is also 1 time. And for the symbol M, 2 times, I 1 time, T 2 times, E 2 times. So these are the probabilities for the symbol COMITE. Then in the next step, you have to arrange all these symbols in descending order. That is 2 by 9 here. Next 1 by 9. We have to arrange these symbols in descending order, and for the last two symbols we have to write for the top symbol, that is 0, and we have to write 1 here. Then rearrange these symbols in the descending order again. Here it is when we add 1 by 9, 1 by 9, it is 2 by 9. So we have to write here, and this will be right at the bottom of this 2 by 9. So Here we have to arrange again 0 1, assign 0 1. Next you have to write the all the symbols in descending order. Then assign the 0 1 for the last two symbols, that is 0 1, and for the we have to arrange all the symbols in descending order. When we add 2 by 9 2 by 9, we get the 4 by 9 here, and it is 3 by 9, it is the 2 by 9. Next 0 1, after writing this 0 1, how to add this 3 by 9 and 2 by 9, that is the 5 by 9 here, and it is the 4 by 9, that is 0 1. Then we have to collect these bits 0 or 1 for the each symbol. Suppose if you take the m, the bits are here. For the m it is 1 0. We are taking from left to right, so we have to write from the right to left, that is 0 1, that is 0 1. For the word it is 0 1. Next for the T it is 0 0 1, that is we have to write 0 1 0 1. Next for the E it is 1 and it is 1. So the E it is the 1 1. Similarly we have to write the code words for the COI. This I, for the I it is 1 0 0 0, that is 1 0 0 0. These are the code words for these symbols MTECOI in the word committee. And the word length, these are the 2 bits, and this is also 2 bits, and it is the 2 bits 3 4 4, that is the word length. And next, how to find the efficiency. First you have to find the average length, and it is the formula for the average length, that is sigma k is equal to 0 to n minus 1 pk lk. That pk is the probability of occurrence of the symbol, kth symbol, and lk is the length of the kth symbol. Then we write by writing this lk and pk, that is the length of that code word and probability of that symbol. We have to find the average length. Next, after finding the average length, we have to find the entropy, that is the h of s. H of s equal to minus sigma k is equal to 0 to n minus 1 pk log base 2 pk on minus 1 by 0.3010 sigma k equal to 0 to n minus 1 pk log base 10 pk. By using this formula, we have to find the h of s and efficiency. Next, efficiency equal to h of s by L bar. Here we get the 97.9797%. That is the Huffman coding. We get the compression, image compression, and we can reduce the coding redundancy, because here we are assigning the less number of bits for the highest probability bits, highest probability symbols. So we get this image compression, or we can reduce the coding redundancy, and it is a variable length coding redundancy. We reduce the coding redundancy. It is a variable length coding, because here the number of bits assigned to the each symbol on variable length coding. We get the image compression, and it is a lossless compression, because we are assigning the particular code words for the symbols, and we can reassign that bits, that intensity values based on that code words. It is a reversible, so it is a lossless compression. Thank you.